Hello students, welcome back once again to another video in your favorite channel Frank Guruji. आज के इस वीडियो में हम कोवेलेंसी के बारे में पढ़ेंगे. Today we will learn about covalency. You know, with the help of covalency we are able to draw the structures of various compounds easily. So I thought, why not do a video on covalency? So let's start the video without any delay. So the topic covalency. Okay, covalency, you know, in simple terms, covalency means number of bonds formed by an atom in neutral state, but some atoms can also show covalency in excited state. So we will learn about them also. So let us start learning, or let us know the meaning of covalency with an example. Say hydrogen. Hydrogen, its atomic number is 1, so its configuration is 1s1. So how to know what is the covalency of an element? We can know the covalency of an element by finding out the number of unpaired electron that is present. So it has one unpaired electron in it, so its covalency is 1. Now let's straight away move to carbon. Carbon's atomic number is 6, so its configuration is 1s2, 2s2, 2p4. Okay, so you can see in its outermost shell, this, if I write in this way, 2s and 2p, it is 2p2, I'm sorry. This is the electronic configuration of carbon in ground state. Okay, now in the excited state, what will happen? It will have, you can see there is a vacant p orbital, so this electron can come here. So there are 4 unpaired electrons. So that means covalency of carbon is 4. Now you can ask, sir, why not covalency of carbon is 2? It is having 2 unpaired electrons. Actually, if we take 2 unpaired electrons in case of carbon, it is found that it does not obey the octet theory. So that's why we cannot take covalency of carbon as 2. We have to take covalency of carbon as 4. And how do we find this? In order to find this, we have to think of the excited state. In the excited state, we see that there are 4 electrons. So these 4 electrons can combine with electrons of other atoms, unpaired electron of other atoms, and form 4 covalent bonds or 4 bonds. So that's why covalency of carbon is 4. That means it can form 4 bonds. Now let's check what is the covalency of nitrogen. So nitrogen, that is the 7th element, nitrogen. Its atomic number is 7. Let us write its electronic configuration: 1s2, 2s2, 2p3. See, if we write the outer shell electronic configuration, it is something like this. This is 2s, this is 2p. Now one thing, see, nitrogen does not have any vacant d orbital. If you remember, after 2s, 2p, it is 3s. Nitrogen does not have any vacant orbital. So the covalency of nitrogen is found from the ground state itself, that is 3 only, because here we are seeing there are 3 unpaired electron. So these 3 unpaired electron gives nitrogen what? Covalency equal to 3. That means it can form 3 bonds. So in excited state, no covalency. You have to remember this. After this, let us move on to oxygen. Oxygen 8. Let's write its electronic configuration, that is 1s2, 2s2, 2p3. So we will have this is the configuration of oxygen in the ground state, and you can see that there are only 2 unpaired electrons. So covalency of oxygen is 2. Please note this. So that means oxygen can form only 2 bonds, and in case of oxygen also there is no excited state possible because there is absence of vacant orbitals. Now let's move on to fluorine. Fluorine क्या है? Fluorine 1s2, 2s2, 2p. Fluorine is 9, 2p5. So this is, I am writing the outer shell configuration, 2s, 2p. So you can see there is only 1 unpaired electron. That's why covalency of fluorine is 1. That means it can form only 1 bond. Okay, and it cannot extend its covalency because there is no vacant orbitals present here. Now let's move on to the next element, that is phosphorus. Phosphorus, that is 15, 1s2, 2s2, 2p6, 3s2, 3p, so up to 10, 12, 3p3. So this is the configuration in ground state. So in ground state we have 3s and 3p. So in the ground state, covalency of phosphorus is 3 because there are 3 unpaired electrons. Now you know that after 3p there is vacant d orbital. So in the excited state, what happens? These electrons from S, 3s, 3p, 3d, this can move here also. So from this we see that its covalency is now 4. Okay, so phosphorus can have 3, 4, 5, not 4, it is 5. I'm sorry, you can see it's 5. Phosphorus can have covalency of 3 in the ground state and 5 in the excited state. That means it can form either 3 bonds or 5 bonds. We can see in PCl3 it is forming 3 bonds, and in PCl5 we can see it is forming 5 bonds. So that means because of presence of vacant d orbital, it can extend its covalency. Whichever element has vacant orbital, that can extend its covalency. Okay, so the possible covalency of phosphorus is 3 and 5. Now let's move on to sulfur. These are the elements that forms the compounds, important compounds. That's why you should know the covalency of these elements. Next, sulfur. Sulfur, you know, 16, that is 1s2, 2s2, 2p6, 3s2, 3p4, okay, 10, 12 plus 4, 16. So we will write the outer shell configuration, 3s, this is 3s, this is 3p, so in the ground state, covalency is what? Covalency, you can see 2 unpaired electron. Now let's say in the excited state, what will happen? These 3s, 3p, this is 3d. This electron can move here, that means 1, 2, 3, 4. In this case, covalency is equal to 4. Similarly, we can find another excited state. This is excited state 1, this is excited state 2. So this one also can move on to the next vacant orbital and give sulfur a covalency of 1, 2. So 1, 2, 3, 4, 5, 6. So here covalency of sulfur is 6. So that means sulfur, important element, can form 2 bonds in some compounds, 4 bonds in some other, and also 6, like in SO2. It will form 2 bonds. In case of SF4, it will form 4 bonds. In case of SF6, it will form 6 bonds. So with the help of theory of covalency, we can find out the number of bonds formed by an atom. Now let's move on to the chlorine atom. In chlorine, you know, the configuration is 1s2, 2s2, 2p6, 3s2, 3p5. So in ground state, its covalency is 1, but in excited state, it also shows other covalency like 3, 5 and 7. So please remember these covalencies. And one more important element that I would like to tell is xenon. You know, xenon shows covalency of large number of covalency, 2, 4, 6 and 8. 2, 4, 6 and this 8 in excited state. So if you know the covalency of various elements, it will become very easy for you to draw the structure. So let us again wind up this lecture. In today's lecture, we have learnt about the various covalencies of the element. See, this is the element and this is the covalency. First, we have learnt about hydrogen, only 1. Then we learnt about carbon, 4. After to nitrogen, covalency is 3. Oxygen, 2. Fluorine, 1. We can make another table here. Covalency, element, C, fluorine. Then we learnt about phosphorus. It has 3 and 5. Sulfur, 2, 4, 6. Chlorine, 1, 3, 5, 7. And last, xenon, 2, 4, 6 and 8. If you know this, if you remember this, it will be very easy for you to write the structures whenever you are asked to draw a structure of a particular compound. So that's all for today. Please go through this video if without skipping from start to the end. If you like the video, please press the like icon and also share the video and ask your friends and relatives to subscribe my channel. So until the next video, it's all the best.